So the biggest difference when coming to Scala, from Scala to Rust, would be that, well, you don't have the garbage collector, right? And this is no, it's not fun. Sorry. I really tell you, it's not fun, and JVM is a great thing, so it's not so fun as you might expect. Yeah, so I've been working at Toke, Newsnacker, Scala, and whatever. Yeah, and this one I've created. This is the company I'm currently working on with Rust and Python, so let's not care too much about this one. Yeah, I've come to, and this is the syntax, right? So as you can see on, I don't even remember, on the left is Scala, on the right is Rust, so pretty similar. The biggest difference here is that you have Xmatch in Scala and matchx in Rust, which is so annoying for the first half of the year. And then I discovered in our code base that you can actually write code in Rust that's kind of like pretty similar to your usual Spring code. You have you can write code with repositories, services, and whatever. Of course, not very idiomatic because it was littered with boxed in and cloning and so on. Anyway, as I've said, the biggest difference is that, okay, so I've moved from JVM and garbage collect language to something much more level, right? Much more low level. And yeah, I needed to accept the rules. And surprisingly, I was really afraid of it, right? Because this is the assumption that, you know, I'm just a Java guy and I don't know how to deal with the memory. But coming from Scala, it was surprisingly easy. And yeah, I think what I discovered is a few stages where you kind of like ingest the memory rules into your mind, I would say, starting from, you know, understanding the iterator, why it needs to take mute self and so on. This is exclusive reference. And then you have this kind of like enlightenment when you go, for example, to landing iterator, and then you finally realize why you even need those lifetimes, why would it be helpful? But it was, coming from Scala, it was kind of like surprisingly easy. And the way what helped me to think about it is that in Scala, you know, it's kind of like a more like functional programming language. There are a lot of effect systems and so on. And if you think about ownership roles and all those mutable exclusive bars and so on, it's kind of like a effect system, then coming from functional programming makes your life just a little bit easier, right? And of course, you need to get used to some of the quirks, like for example, you know, in JVM or garbage collected languages, you don't have a full control where the object will be really dropped, right? So anything like finalization is kind of like considered as something not really stable, whereas in Rust, I can totally control, right? When the thing gets dropped and have various things like closing the files or cleanups in the drop. So that was kind of like really something that opened my mind, I would say, to a new world. Of course, I still have some doubts whether this drop thing is such a good thing, because currently in normal Rust, it can either not return any error or panic, which is kind of like, I still don't feel too good about it, but hopefully at some point we will be able to write a function like this. But all those rules were kind of like the easy part, but the more problematic one was this kind of like cognitive load of always thinking whether I need to clone or I should clone, I shouldn't, whether it's okay to allocate a new memory or not. And this is the biggest, I feel this is the biggest problem we're coming from garbage collect language, right? Because, okay, still, in most cases you can clone, right? But at some point your code starts to be not so idiomatic. And this is what I kind of like feel that is a significant cognitive burden, right? That you can write this function like this, like this, like this, and all the time you need those decisions, right? Do I need to own the string? Can I just have a slice or something like that? Whereas in garbage collected languages, you don't. You just have a string. Let's deal with it and move on with our lives, right? And this goes even further, right? It took me quite a while to acknowledge that there are so many conversions methods, for example, in the standard library, and that there are some, I would say, rules, right? That a method can be called as, to, and into. And from people coming from JVM, to comprehend that into just takes the ownership, that to creates a new owned object, but takes only reference, and as is kind of like just this kind of like simple recursion. It's kind of like, yeah, as I said, this is a lot of to think of, a lot of cognitive burden. So it's this part I think still is a bit problematic even after those 2 years, and only after a while I kind of like understood that the thing is that the difference between JVM, garbage collected languages, and Rust is that, okay, so here the allocation is kind of like significant moment in program's lifetime, right? When you code in Scala and JVM, unless of course you do some kind of like high frequency trading stuff, then you don't care too much about allocation, right? You trust the JVM, you trust that it will be either optimized or the garbage collector will be fast enough. But here, you can spend endless hours debating whether I really need to allocate or not. And if you think about it, it goes even further, right? Because think about it, on left hand, we have Scala code and right Rust. They look deceptively similar, right? But if you think what is happening, then actually what happens when you create those kind of like containers can differ a lot, right? Because in Rust, most of the time, it will be kind of like more stack allocated, whereas in Scala or JVM, you are kind of like more used that everything will be on the heap. Everything. Well, unless the mighty JVM decides to do otherwise, right? Because in JVM, there are kind of like multiple optimizations, and in fact, this container might on the stack if some. Oh, let's not get into JVM optimization because this is not Scala conference. But even if the syntax is similar, right? The way how things works under the hood can be very, very different, and it takes quite a while to get used to the fact that in Rust here, it might happen that there will be no memory allocation. Of course, we're not talking about the back, but you know what I mean. And this is because this allocation is kind of like, as I said, this significant moment in program's lifetime. Then you find yourself writing code more or less like this. For example, reusing this string buffers. For example, in my team, in one of the refinements, I don't remember yesterday or something like that, we did spend some time debating whether in some critical, from terms of performance, piece of code, we should reuse this string buffer or not, right? And again, in Scala in Java world, it'll be kind of like a bad taste in many ways, right? A string is a string, you don't care too much, and so on. So it got me quite a while to get used to the fact that, yeah, you can and should reuse some mutable structures like this. And of course, after spending some time in the Scala world, I was thinking like, yeah, mutability is bad, right? And so on, as probably the colleagues from SoftwareMill may attest. But in fact, if you think about what the people from functional community says, is that shared mutability is the root of all evil, right? And mostly in Scala world, we are kind of like more concerned about this mutability part. And it took me a while to understand that, yeah, the Rust is also saying that shared mutability is the root of evil, but in Rust, it's kind of like more about controlling the shared part than the mutability part, right? So again, this is still, some basic principles remain the same, but we're looking at them from different angles. And after a while, I got used to the fact that, for example, you know, Scala, it's kind of like, it was more common for me to write code that works by recursion and so on, and even doing some quite complex recursive invocations. And here, at least in the place I'm working, we're kind of like more tending to use this kind of like a little bit more imperative style with stack-based things and so on, just to tweak some kind of like performance or reduce the need for recursion, which is also took me a while to actually ingest it and understand that this still might be fine. Although I still feel the recursion is a good thing, but looking at all those RFCs for for adding some kind of tail elimination and tail recursion to Rust. Yeah, if you can see, they are kind of like they are here for like 10 years and still counting. So I still feel that hopefully we'll get somewhere with the Rust. I don't have too much time because of the technical difficulties, so that's why we'll be talking fast. And the second bigger thing that I want to talk about is the differences and my kind of like experience with type system of Rust compared to Scala. And again, at some point, of course, the slides should be animated, but you will see everything in one go because this is PDF. Because my laptop decided to let me down. So I don't really remember. On the left hand, you have types in Rust. On the right hand is Scala. And you can see that, you know, everything is there. There are generics, there are structs, which are named kind of like case classes. You can have a function types. Syntax is a bit different, but still it's kind of like similar. And also some more advanced features, like you have tried in Scala, you have tried in Rust, you have, you know, type parameters and so on, generics. Everything looks pretty similar. So at the beginning I thought, okay, this will be an easy, right? But then as you dig deeper, it turns out that it's about more elaborate. And this is something that I want to show, and this is something that I really think is so cool in Rust type system, that you can write those kind of like more advanced type bounds. I think you can do them in Scala, at least in the newer versions, but still you would probably struggle a bit. And this is, you know, this is kind of like, I think it's a piece of our code base, and I didn't even need to obfuscate it, right? You still don't understand what it's doing, right? but the thing is that you can do pretty advanced stuff, and the compiler won't hurt you. And yeah, so for me, this is something that's kind of like really impressive in Rust type system. But coming to the trait, as I said, we have trait in Scala, we have trait in Rust, and they look deceptively similar, but in fact, they are trying to describe something else, right? Because in Scala, where is Scala? Ah, this is Scala, sorry. I am even confusing myself. So here it's kind of like more of a concept from object-oriented programming, which we don't have in Rust because we don't have objects. Whereas in Rust, it took me a while to understand that actually what this trait is something that is called type class in Scala, and this is how you would do it in kind of like modern Scala that I don't understand too much because I'm an old person. But again, ask the organizers and they will tell you. So the names are the same, but they can describe a bit different concepts. But still, both in Scala and Rust, we have the type class, and this is something that I found pretty cool. But then there are also some subtle differences that makes you wonder which one is better. Because in Rust, we have these coherence rules saying that you cannot implement trait for foreign crates, or that you cannot have two implementations of the same trait for the same object, right? And of course, you can get away with new types and so on, but it's kind of like annoying. But I can tell you that it is so much better than some things that you can have in Scala when you have where you have a pretty complex rules saying which trait implementation will be chosen, right? And if you go to Scala, you can see some weird things like low priority implicits and so on, which will make your head hurt. So this is something that I want to say that, yeah, this is a bit more restricted, and the rules are more restricted in Scala for the traits implementations, but still, I feel this is very good because it makes reasoning about your code much easier. The compiler and the Rust analyzer also do not hurt your laptop's fan, as usually happens for Scala, right? So I feel this is something that's kind of like really worth it. Oh my God, I have so little time. But let's not worry too much. And still, even after digesting this type class things, after a while, coming from JVM, you will come to yet another obstacle, and this is kind of like, again, something that takes quite a while to digest and understand. And this is, we still have our case class, we implement some traits and so on, and then when we want to use it, right? This is how we would do it in kind of like normal, I would say, JVM or Scala world. You say, okay, try the objects, man, just the anymore. And you're thinking, what? And then you discover one of the bigger differences in terms of how the types and generics are working between JVM and Scala and Rust. And this is the thing, right? Because here, the generics, and here is Scala, the generics are subject to kind of like type erasure. And by default, all you have is dynamic dispatch, whereas in Rust, we have monomorphization of generics and static dispatch by default, right? Of course, you can do the boxed in and the usual machinery, right? But in many places, it's considered, at least this is what I met with, it's considered kind of like cheating and not idiomatic, right? So this is something that sometimes that is kind of like difficult to get used to after so many years working with dynamic dispatch, right? That you need to pass all those type parameters up to the point where you usually somewhere closer to the beginning of your program where you really decide what trait implementations do you want to use. But at the same time, if you think about it a bit more, you can feel that again, there's some thinking in it. And for me, it's kind of like a good that I need to write all those type parameters so that they can be monomorphized, because this makes my kind of like type dependencies more explicit. It's similar to what SoftwareMill was propagating in terms of dependency injection, not to have those magic Spring instances injecting things wherever you want, but to construct your object graph at the top. And I think this is something similar a little bit. This is my feeling at the type level. I'm kind of like a bit vague at the moment, but in the end, I just got used to and ingested this monomorphization stuff, and I feel, yeah, this is cool. Which brings me to yet another topic, and this is again thinking, okay, so we have type classes, we have generics and so on. Can I do functional programming or something similar in Rust? And this is where it gets a bit more complicated, because if you think about it, on the left-hand side, you have your normal Scala code with kind of like for comprehension when you have things like monads, and you kind of like compose the effects that they provide. And on the right-hand side, you have kind of like analogous code in Rust. And of course, here you have the mighty question mark operator. And they look kind of like similar. And you might think, okay, is it the case that the question mark operator in Rust is kind of like form of for comprehension, and I can do my usual functional programming? Well, if you go to, for example, operations on the collections, then you can see that it's not so easy, because there's far more ceremony in Rust than in Scala, also due to the fact that we need to care about the memory and so on. So here it's kind of like more similar to how Java operates on collections. So yeah, this is not so nice, but still, if you go even deeper, you could see that, yeah, in Rust we have vec, option, and result things that in functional programming Scala world would be called monads, but then the naming is so inconsistent. This is something that really kind of like annoyed me at one point, that you can have a flat map for values, but for option and result you have and then, which is kind of like so, yeah, you look at them and you feel, yeah, those should be called flat map, but they don't. So but these are kind of like small annoyances. The bigger problem is that this question mark in Rust you cannot implement your own, right? You can have it on a result, on option, but you won't be able to implement that, for example, for the vec, right? So this is, things may change and so on. I can understand the reasons that there is some, how to say this, that there is some logic around the performance and memory allocation, but yeah, this is kind of like something that tells me that, okay, it's not really the same. And also then, if you try to do kind of like, this is at least my feeling, that if you try to do a little bit more elaborate higher order functions returning functions, then quite soon you'll hit a wall where your functions type will be tried to be monomorphized, and it will be not so easy to do things that you would find easy in the Scala world. Yeah, I know I'm also almost over time, but I'm almost done, so don't worry. Yeah, so my thinking is like, yeah, I can try to do some of the things that I try to do in Scala in terms of functional programming, but just because I can, it doesn't mean that I should, right? This is kind of like my final thought that, yeah, this language is different, and yeah, you should, maybe you shouldn't try to do this. And the last a few bits that I wanted to talk about is tooling. So first, the cargo is so great when compared to JVM and Scala ecosystem. That is standard, has all the things built in. This is so great. Not going too deep into that. Also, what is kind of common for Scala and Rust is long compilation time. But the different thing is that in Scala, most of the time is spent in the type checker because it can do some crazy things and so on. And for us, it's more about the final optimization. So debug compile is still kind of like quick, but then, yeah, if you want to compile in release mode, it's different. So the compilation time just takes time at different stages, which also kind of like drive you to different ways how you work. Also, one interesting thing when it comes to tooling and the libraries is the fact that due to Rust being kind of like more statically linked, you can have kind of like daemon dependencies, which is a real hell, a real problem in the JVM world, when you cannot have, your application, it depends on two libraries, and one is depending on the first version of logging, and second one depends on the other, right? This is kind of like really massive, unsolvable, okay, not unsolvable, but very difficult problem in JVM, and Rust is kind of like, yeah, you can do it. Everything is statically linked, so this is fine. Of course, until your app is really using this stuff from both versions, right? But still, it's in some sense it's much nicer. And also, when you go to kind of like production, your backend service, there are some things that I'm really missing from JVM, and the fact that you do have a runtime there, that you do have the mighty JCMD command that can dump your threads, get heap dump, even modify some parameters and so on, right? And in Rust, you should decide about almost everything upfront, just as we've been told, right? That during the compilation, before I even build, I need to decide whether I want to strip, whether I want to include debug symbols and so on, right? So I'll have one binary for debug, one for production, and this is so annoying, right? Whereas in Java, I just have a jar, right? I put it wherever I want, and it just works, right? So this is about ergonomics. I won't be talking about async because half of the conference is about that, and yeah. And I would say my final thoughts is like the first thing is I feel the Rust type system is kind of like really great. After so many years working in Scala, I really appreciate also some of the design choices that are here, but adjusting the different paradigms is kind of like, this is surprisingly difficult, especially if you want to write kind of like more idiomatic code. And it's very interesting to observe, similar patterns, similar constructions that work differently because of different trade-offs. But in the end, if I were to decide when to use Rust and when to use something else, I would say that on data plane, fine, but on the control plane, sorry for folks from SoftwareMill, I should have put Scala there, but I decided to put Kotlin, right? But on the control plane, I feel that garbage collection stuff would be in a way much easier. And this is something that I want to end, because this is similar to both Scala and Rust communities. So this is the normal both Rust and Scala team debating the ideal code, right? People from my team know who the plateau is, and I'm of course Diogene, and we are debating the best and ideal code, whereas the deadlines are going, but we don't care. We're discussing whether to allocate, whether to put a monad hero there, and so on. Yes, so my deadline also has passed, and thank you, sorry for the technical difficulties, and I hope you enjoy the conference.